Hi, my name's Graeme and I'm the Chief Geodesist here at LINZ. This afternoon I'm going to tell you a little bit about one of the world's oldest sciences, and that's the science of geodesy, which is the study of the shape and size of the Earth. So have you ever considered the shape of the Earth? If you get back into space and you look at the Earth, you see this nice round circular globe rotating in the sky. But if you were to take a closer look at the Earth, you'd find, and here you can imagine that I have one finger sitting on the North Pole and one on the South Pole, you'll find that the Earth is slightly shorter across the North and South Poles than it is across the equator. So it looks a bit like a hula hoop. If I had a hula hoop and I squashed it from top to bottom, I'd have an ellipse. If we then rotated it through 360 degrees, we would have mathematically what we would call an oblate spheroid, which approximates the shape of the Earth. But if we could imagine that imagine that water, and if it was to permeate under all the continents, and if the shape or the surface of the sea level going under all the continents was to give the actual shape of the Earth, then we would find that the sea surface would deviate from this oblate spheroid, this nice mathematical model, by about plus or minus 60 to 70 metres. And that really gives us the shape of the Earth. So we have this Earth, as defined by sea level, which has all these humps and bumps on it. So rather than looking like this nice round regular shape that I had, it actually looks more like an orange. It looks like the orange peel of an orange with these humps and bumps on it. And a bit like my orange here, we could imagine perhaps a world or an Earth which has New Zealand sitting on it in this rather irregular shape. And like the world, we have the concept of plate tectonics, where the Earth's crust is broken up into large plates which slowly move against each other. And they move by anything between a few millimetres up to perhaps 7 or 8 centimetres a year, which is about as fast as your fingernails grow. So on my orange here, I have one of these plates, and I'll call this the Pacific plate, and that plate boundary just happens to run down through New Zealand. And so we find that as this plate is slowly moving, it's causing New Zealand to slowly deform, and then as the plates collide, we get a build-up of pressures, we get a sudden movement, and we get an earthquake. So one of the things that we do here at LINZ in the Geodesy group is to take this rather complicated world we live in, this bit of an orange peel, and for surveyors, we actually don't want to be concerned about this rather complicated shape we're on. We want to have a survey network which enables us to be able to project everything down essentially onto a flat piece of paper. So we can take our lemon peel and try and flatten it out. And we see that that's a bit difficult to do. So we provide the mathematical systems and what we would call the datums, the reference frames, to enable surveyors to connect in to a network of marks, and sometimes those marks are electronic marks, what we call permanent tracking global navigation satellite system marks or core stations. And by connecting into those marks, then surveyors can do their computations in a regular way so that we can have a stable reference frames which accommodates the movements that occur due to plate tectonics and earthquakes. And that's one of the functions here that the Geodesy group within LINZ is undertaking, to provide those stable reference frames to enable surveyors such as engineers, cadastral surveyors, to define property boundaries, to be able to install stormwater and water systems to ensure that water runs downhill, which is really important for when you're putting in water systems. So that in a very short manner is really describing what our Earth looks like. You want to consider the Earth not so much as a nice round ball, but perhaps more like an orange, with a thin outer crust and a soft inner core, with this rather strange humpy bumpy surface. And that is just part of the role of the geodetic group and what geodesy is all about.